The device in your pocket is more powerful than the computers that landed humans on the moon, but how does it actually work? It's honestly an incredible piece of engineering, but most of us just treat it like this magical black box, right? Okay, let's dive right into this explainer and physically and conceptually deconstruct the smartphone to see exactly what's happening under that glass. To really put this into perspective, we have to look at the sheer mind-boggling scale of this tech. Get this, as of 2020, 75.05% of the entire global population were smartphone users. I mean, that's wild. It's arguably the most rapidly adopted consumer technology in human history. We literally rely on them constantly. Yet, very few of us actually know how the metal, glass, and chemicals in our hands work together to connect us to the whole world. So here's our blueprint for today. We'll start with the ultimate convergence device, explore the magic of touch, then look at central processing, examine the lithium-ion power plant, see how we fit cameras into our pockets, and finally, wrap it up with the pocket-sized supercomputer. Let's get into it.
Section 1. The ultimate convergence device, the tech that ain't everything. Right, so to truly appreciate the internal engineering we're about to explore, we first have to understand what a smartphone actually is. It is, basically, a technological black hole. Just look at this list. Before the late 2000s, you'd literally need an entire backpack to carry around a personal digital assistant, a portable MP3 player, a point-and-shoot camera, a standalone GPS for your car, a calculator, and, an alarm clock. The smartphone just absorbed all of them. And this massive convergence, that's exactly why the hardware inside is so incredibly impressive, because it has to do the job of a dozen different machines all at the exact same time.
Section 2. The magic of touch, the sensory skin. So the first major step in this modern convergence was ditching the physical keyboard to make room for a massive screen. But actually, that raises a pretty fascinating question. How does touching just inert glass trigger a mechanical action? It kind of feels like magic, right? You tap this dead piece of glass and a digital button reacts. Well, it all happens in literally nanoseconds through a tight collaboration of three things: a touch sensor, a controller, and software. When you touch the screen, the sensor detects that physical interaction, the controller instantly translates it into a digital location coordinate, and then the software tells the operating system exactly what to do at that specific pixel. But, not all touchscreens are created equal. Older or really specialized systems use what are called resistive screens. Those require actual physical pressure to push two metallic layers together just to complete an electrical circuit. You've probably used them, usually with one of those little plastic styluses. Contrast that with modern smartphones, which use capacitive touchscreens. And this brilliantly illustrates a huge leap in design. See, capacitive screens use a layer of material that holds an electrostatic charge. Because the human body naturally conducts electricity, when your finger touches the glass, you aren't just pressing it. Your finger actually disrupts that electrostatic field. The touchscreen detects the natural electrical signals inside your finger to pinpoint your exact location. Your body's electricity is quite literally completing the loop.
Section 3. The brain. Central processing.
Okay, so the skin registers your touch. Now, that signal has to be sent to the brain of the device. Deep inside your phone is the Central Processing Unit, or CPU, which is generally integrated into a highly efficient, low-power CMOS system on a chip just to save space. This glowing processor is performing billions of calculations every single second. Seriously, billions. And no matter how complex an app is, the CPU is basically doing three fundamental things over and over again in what we call the instruction cycle. Step 1, fetch an instruction from the memory. Step 2, decode what that instruction actually means. And step 3, execute the command. What you should really take away from this is that whether you're just casually swiping on a photo or rendering some crazy high-end mobile game, this invisible three-step process is happening instantly, billions of times per second.
To actually execute those commands, the CPU relies on two major components. The control unit acts kind of like an orchestra conductor. It doesn't actually play the instruments, right? But it provides the timing signals and directs the flow of data between the memory and the hardware. Then, the actual heavy mathematical lifting, that's done by the arithmetic logic unit, or ALU. This is a combinational logic circuit that performs all the hardcore arithmetic and bitwise operations.
Section 4. The power plant. Lithium-ion.
Of course, the brain absolutely cannot function without power. Pushing electrical power to every single component requires this tiny, miniaturized chemical power plant known as a lithium-ion battery. And the secret to your smartphone's battery life is this chemical process called intercalation. Essentially, this is the reversible embedding of lithium ions into porous electrode materials. So the crucial point here is that word reversible. Because the chemical reaction can flow in both directions, we can drain our batteries during the day, plug them into the wall at night, and totally reverse the chemical state, making our phones rechargeable over their lifespans. Let's look at a quick micro-narrative of what actually happens when you use your phone. A battery consists of an anode, which is often made of graphite, and a cathode, which is usually a metal oxide. When your phone is unplugged and discharging, an oxidation reaction at the anode releases electrons. These electrons flow right out of the battery, power the circuits in your phone, and eventually arrive at the cathode. Meanwhile, the positively charged lithium ions travel straight through the internal electrolyte to meet them. Then, when you plug your phone back in, you force those electrons back the other way, completely resetting the whole system.
Section 5. Fitting cameras in pockets.
Now that we've got the skin, a brain, and power, let's talk about the phone's eyes. Smartphones have fundamentally changed photography, effectively wiping out the entire market for dedicated point-and-shoot cameras by taking almost a third of all photos globally. But putting a camera in a smartphone presents a massive physical challenge, mainly the total lack of depth. Traditional cameras use deep physical lenses to achieve focus and optical zoom. To get around this, engineers utilize a camera bump just to buy a few extra millimeters of physical depth. They also use multiple specialized, tiny lenses, like telephoto and wide-angle, placed side by side. But honestly, the real magic is computational photography. Instead of relying purely on glass optics, the smartphone transforms physical light rays into instant digital images by using that super powerful CPU to process and merge multiple frames instantly. This offers wild features like night mode and artificial depth of field, saving them in standard JPEG or high-end RAW formats.
Section 6. A pocket-sized supercomputer.
So when you combine the capacitive touchscreen, the multi-core CPU, the rechargeable lithium-ion battery, and the advanced computational cameras, what you are left with is quite literally a pocket-sized supercomputer. But there's a final, invisible layer tying the whole shebang together: sensors and connectivity. Your phone constantly fires off invisible mobile and Wi-Fi signals connecting you to the entire internet, while internal sensors monitor the physical world around you. They have accelerometers and gyroscopes, so the device knows exactly how it's being held, allowing the screen to rotate automatically. They have ambient light and RGB sensors that seamlessly adjust your screen's brightness and color temperature. And beyond that, many phones actually measure atmospheric pressure with a built-in barometer. Software apps use this data to calculate your altitude in real time, like tracking how many flights of stairs you've climbed today. Now, it is absolutely impossible to overstate how deeply this technology has integrated into our daily lives. The convergence of so many tools into a single device brings unparalleled convenience. However, as noted in the source material, this massive societal shift definitely comes with trade-offs. The constant connectivity and screen time have been associated by researchers with various negative effects on physical posture, mental well-being, and cognitive focus. It is an incredibly powerful tool, and, well, like all powerful tools, its impact depends entirely on how we interact with it.
We've seen how the smartphone absorbed the camera, the map, the music player, and the calculator through a brilliant combination of microprocessing, chemistry, and sensory tech, which leaves us with a really fascinating question to ponder as we wrap up. As processing power continues to grow and components shrink even further, what standalone device sitting in your house right now will your pocket supercomputer absorb next? Think about that next time you tap that glass. Now you know why your smartphone is one of the most advanced machines ever created. Follow for more amazing